Okay, so if you go back and look at my previous video on Q and K, you'll see that we know that under these conditions we're going to be shifting to the right, going towards the products. Okay, so now what I'm going to do is I'm actually going to set this up as a race chart, and we're going to find the final concentrations at equilibrium in this video. Okay, we're going to use a TI-84 graphing calculator in order to do this, but any other graphing calculator could do this as well, and in this particular case you could use the quadratic formula also. So the first thing I need to do is look at the reaction. So okay, for a rice chart we're just going to look at reaction. So we have 2SO2 plus O2, okay, going inversely to 2SO3. Okay, those are all gases. Alright, now looking at the I stands for the initial, so the initial concentrations of each, and we're given that. So for the SO2 it is 4.0 times 10 to the negative third molar. For the O2 it is 3.5 times 10 to the negative third molar. And for the SO3 it is 4.0 times 10 to the negative second molar. Okay, so those are our initial concentrations. Now comes the part where we need to deal with a change. So we already said we're going towards the products. If you go back and look at the last one, you can see that Q is less than K in this case, so we know we're going to add to products. Okay, so it's going to be a plus over there, minus, minus. Okay, we're going to use up reactants to make it. Now comes the amount. Well, we're going to simply sort of plug in X for the amount, and we know that because of the balanced equation here, it's 2X for that. So if it was X was 1 molar, we would use 2 molar SO2 and X, or 1 molar O2, and that would be plus 2 times X of SO3. Okay, so that balanced reaction becomes pretty important here. And then out of this we get our equilibrium concentration, which is 4.0. So I'm just going to drop that for now to make it fit. 4 times 10 to the negative third minus 2x. The oxygen will be 3.5 times 10 to the negative third minus x. And the SO3 will be 4 times 10 to the minus second minus, plus 2x. Okay, and those are all going to be molarities. Okay, so now in order to solve this, what we need to do is plug those values at equilibrium into the K reactions at equal. So we know that Kc is equal to concentration of SO3 equilibrium squared over concentration of SO2 squared times concentration of O2. So if we plug these values into it, what we're going to say is 7.9 times 10 to the fourth, okay, the K sub C, is equal to, and the equilibrium concentration of SO3 we have right here, 4 times 10 to the negative second plus 2x, and that is going to be squared, divided by, and we're going to put in the SO2 next, 4 times 10 to the negative third minus 2x, that quantity squared, times 3.5 times 10 to the negative third minus x. Okay, so we have on the left here just number, and on the right here we have the expression of those equilibrium concentrations in terms of x. We can solve this. We could solve it with quadratic formula. Actually, it's going to be a little more complicated because now that I look at the bottom, we've got we're going to have x to the third, but the best way to do this is to use a graphing calculator and just do an intersection of the two graphs. We could cross multiply and do that first. I prefer to just do the value on the left as y1 in our calculator and the value on the right as y2. So in the next couple of steps I'm going to talk you through how to do that on the calculator. Okay, here, so we have a TI-84, and you can see that I've entered in this case under y1 the 7.9 times 10 to the fourth, the K sub C, and for y2 I have entered the equation that I have, 4 times 10 to the negative second plus 2x squared, divided by this whole quantity, 4 times 10 to the negative third minus 2x squared times 3.5 times 10 to the negative third minus x. Okay, one thing you have to be really careful of with this is that you have the parentheses correct so that you're dividing by the whole thing. Okay, so that's the step for this. The next step is I'm going to hit the window button right here, I'm going to define my window because there's going to be multiple solutions for this, but only one of which is really going to come out to a number that makes sense chemically. Other ones will give you negative molarities, and that's not really going to help. So if we look right here for my window, my x minimum I set as 0. Okay, the minimum, it would be no change, assuming we have it correctly. It's possible it would be negative if we had called the minus 2x in the products instead of plus 2x, but as long as you get your pluses and minuses right, you'll be better than 0. My x max is 0.002. That's simply the value that would turn the initial molarity negative. So if we look really quickly at the rice chart that we created before, this out of the way, you can see right here that if we take 4 times 10 to the negative third minus 2x, if that 2x was greater than 2 times 10 to the negative third, we would have a negative molarity. Okay, so that's the largest value of x we can hit before it, which would be 0 SO2, so it's got to be smaller than that. Okay, that's why I set the x max over here to 0.002. Now for the y min and the y max, I simply just bracketed either side of 7.9 times 10 to the fourth. I called one 7.85, one 7.95 times 10 to the fourth, so we know that's going to show up across the middle. So the next thing we're going to do now is we're going to go and we are going to press on the graph button right here. Okay, and that will show us the graph of the function. So if you give it a second, it'll draw the graph, and we can see that we have our two lines right here is the k. Okay, and this right here is our expression. Okay, it takes it a minute to draw it sometimes to calculate that expression, but that line is that one. Okay, now what we want to find, what we're searching for, is this intersection right here. Okay, that will tell us when the expression is equal to k sub c, and therefore that x value will give us the value of x that we're looking for in order to figure out the molarity change. So the way that I'm going to do this is I'm actually going to go and press on the button second and then the trace button right there, and that will get me calc. Okay, so you go ahead and do that. We pull up this menu, calculate. Okay, and we want to select down here intersect. We're looking for the intersection of those two graphs. So you go down, you press number 5, or you scroll down to number 5, press enter, and it will pop up to a. Okay, the screen will ask you for various things. It'll say graph 1, hit enter, be a little X there. Graph 2, it'll show the expression up here, hit enter. Guess, you can usually just hit enter or try to move the line pretty close, the little cursor close, and it will go and it will solve, and here you can see there's my intersection. It gives me my x value right there. So that is saying that my x value is 6.3 times 10 to the negative fourth molarity. Okay, so given that value of x, okay, that we just solved for, that x equals 6.3 times 10 to the negative fourth molar, we can go through and just plug it in for x over here, here, and here, and get our final concentration. So for the SO2, okay, we can go through and plug that back in. It's going to come to 2.7 times 10 to the negative third molar. The O2 will come to 2.9 times 10 to the negative third molar. And the SO3, which is the one that will increase, will now be 4.1 times 10 to the negative 2 molar. Okay, if you plug the three of these back into the K expression, you'll get 7.95. I think for sig figs it would actually work out as 8.0 times 10 to the fourth, not 7.9. It's the same thing. We're just, because we rounded down to 2 sig figs, it's a little bit thrown off. But you can see that this is how you get it, and now we have those 3 different concentrations of the SO3, O2, and the SO2.